Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. So this is the last series of videos where we'll be discussing theory about related to quantitative aspects of chemical change. Okay. Yes. So what I want us to look at now, it is what we refer to as percentage composition. Percentage composition just referred to as how much a substance contributes. Okay, or a substance contributes by how much. Contributes by how much on a certain compound. For an example, let's have a compound carbon dioxide. So if they were to say to you, let's say, calculate the percentage composition of what? Percentage composition of carbon in carbon dioxide. Okay, what you need to do, just find the molar mass of carbon dioxide. I'm not sure what is happening with my pen, but it is dim. Okay. Carbon dioxide, what is its molar mass? It's going to be 12 plus 2 into 16, which results to 44 grams per mole. So now what is the percentage composition or percentage contribution of carbon in carbon dioxide? So you're going to say percentage of carbon is going to be what? Carbon divided by actually molar mass of carbon, okay, divided by molar mass of the total compound, multiply by 100, which is the same as saying percentage carbon, it is equal to what is molar mass of carbon? We know that it is 12 divided by what is molar mass of the total? It is 44. Then I multiply that by 100. Then I get that a percentage contribution of carbon gives me something like 12 divided by 44. Give me something like 27.27 what percent. Then if I were to check of oxygen, if I were to use the same thing, if I were to check of oxygen, can you see oxygen there? It is going to be equal to what? Oxygen comes with how much? 32 of the total, which is 44. And then I have to multiply that by 100. Then it gives me something like, okay, something like 0.72. So 72.773%. When I add these two, they should give me what? 100%. Okay, yes. Sometimes they do not give you in terms of this, but rather they say, uh, let me see. I want to say something that I might use. A proper example. They might say, I want a proper English in there. Need. Okay. In the reaction below, calcium carbonate decompose, okay, 8 grams of calcium carbonate decompose. When it decomposes calcium carbonate, it forms as calcium oxide plus carbon dioxide. And then they say to you, then number of moles of carbon dioxide, it is equal to something like, let's see, I want us to check something. Mhm. Let's say they give you that. Actually, okay, this one is gonna be no, 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 no. If they say okay, if they say uh during during a decomposition reaction, 8 grams of carbon dioxide, calcium carbonate decomposed. And then the question says the calculate the mass that okay, calculate the contribution of carbon on calcium carbonate. So basically what they're saying is that calculate how much carbon contributes to these 8 grams of calcium carbonate. So or calculate the contribution of the mass of what of carbon on calcium carbonate. Okay. So how are we gonna do that? We're gonna say okay, percentage of carbon in calcium carbonate. Remember, we need to find what is the molar mass of calcium carbonate first. It's going to give us 100. Okay. So we know that in here, carbon comes with what? With 12 divided by 100. This is grams per mole. Okay. Am I correct? 16, 12 years times 100 multiply by how much? Okay. Let's say they want mass of carbon. Let's change the question. Uh, okay. Is my pen lazy or I feel like it's doing something wrong? Calculate the mass of calculate the mass of uh, carbon contribution on calcium carbonate. Okay. Then the mass contribution, and then I need to multiply by 8 grams because I need to know the mass contribution. So it's gonna be 12 divided by 100 multiplied by 8. Then it's gonna give me something like 0.96 grams. Let's look at interesting stuff for the day. Okay. What we refer to as empirical formula. Okay. So when we define empirical formula, it is the simplest uh, rule number ratio of atoms in a what? In a compound. What do we mean by empirical formula? It is the simplest whole number ratio of atoms in a compound. Meaning, if I'm having a molecular formula of C4H10, I can simplify this further to what? Something like C2H5. I'm going to divide this by 2 by 2 so that it becomes the simplest whole number ratio. Okay? So this translates to what? To C2H5. This is what we refer to as empirical formula. This is what we refer to as the molecular formula. Okay, yes. Now, how do I calculate molecular formula? They might give me percentage and all of that. Okay, if I'm given percentage, okay, steps of calculating the empirical formula, the steps. Okay, first one, convert maybe percentage to mass in grams to mass. Okay, then second step, find the number of moles. Then the third step, it is to what? Simplify, divide by the simplest, smallest actually, mole. Let's put that into practice. What do we mean by that? Let's say we are given percentage percentage of carbon is equal to, I don't know how much here. I don't need to use any value. I need to use correct values. Okay. I need to use correct values such as maybe, let me see. Okay, let me quickly go grab a question. Okay, let me quickly find a question here on my phone, on my cell phone. I'm sure I can quickly find that. Uh, where is it? Okay, I do not get any question. Okay, I have one here. I need the one that is in terms of simplest, okay? Oh, okay. Here it is. It says an oxide. Actually, let me go copy that question and come with it. Okay, yes. Okay, now we have an example. It says, I'm not sure if it's visible enough because for me, on my side, my pen has become dim. I'm not sure whether it is flat or what. But it says an oxide, it's now slow, contains 40% of sulfur and 60% oxygen by mass. Determine the empirical formula. Okay, so these are the steps. Remember, I said convert your percentage to mass. Okay, then it means now it's gonna mean that sulfur it is equal to 40 grams and oxygen it is equal to, okay, on this one we are just using O, okay, because we do not know how much it contributes with, so we just write O as it is, not O2. O, it is how much? 60 grams. Then the second step we do what you convert them to number of moles. So number of moles of sulfur, guys, it's back. Like, what's happening? What's happening with this page? Did I do maybe something wrong? It's acting weird. Okay. Then number of moles. Okay, it's now back. Really? Let me okay. No, it's fine. Let's continue. Number of moles of sulfur is gonna be 40 divided by what is molar mass of sulfur, it is 32. Then I get something like, what is this? 40 divided by 32. It's gonna be 5 divided by 4, which is 0, or so 1,25 moles. Okay. Number two, get number of moles of oxygen is gonna be 60 divided by 12, which I want to believe it is 5. Yes, 5 moles. What I want you to do is put sulfur, actually, number of moles of sulfur is to number of moles of oxygen, and then just put them here. Okay, we are not going to be doing the limiting reagent and what. And then remember, step one, it is to convert to mass. Step two, it is to find number of moles. Step three, it is to divide by the smallest number. So just do this. The smallest number here is 1,25. 1,25. Then I get something like 1. 1 is 2. 1 is 2. 4. Then it tells me that, okay, my empirical formula, okay, empirical formula is S. S it is 1, then O it is 0, then how many are they? They are 4. So this is the empirical formula of that particular substance I'm talking about. Can you see how easy it is? Let's look at the second example that you might encounter. Okay. Uh, look at the second example that you might come across. Okay, let's say before we go to this question, let's say you are given that the molecular mass. Yo, let's say you are given that the molecular mass. You are given that the molecular mass. I'll write it here. Molecular mass is equal to something like, let me see, molecular mass, it is 294 grams per mole. Now let's find the molecular formula. Okay, molecular mass is actually 294 grams per mole. And then when they say calculate the molecular formula, okay, what you need to do, you're gonna say, okay, you need the ratio between the empirical formula as well as the molecular ratio. So you're gonna say, let me find the molar mass of my empirical formula, which is SO4. Then it's gonna give me something like 32 plus 4 into 16, which gives me something like 98 grams per mole. And then you're gonna say, okay, what is the ratio between the molecular formula as well as the empirical formula. So you get that it is actually it's gonna be molecular formula. You are given something, molecular mass of the molecular formula, it is 294. Then divide that by empirical formula, which is 98, you get 3. Then it means now, therefore, your molecular formula just multiply by, it's going to be whatever the empirical formula is, multiply by 3. So it means it's going to be 3 multiply, what is my empirical formula? It is SO4. Then it means now my my molecular formula is going to be S3O12. I'm just multiplying these atoms. Okay, yes. Let's look at this one. They say in a combustion reaction, 0.48 grams of magnesium ribbon is burnt. Okay, I have mass of what? Of magnesium ribbon. It is 0.48 grams is burnt. The amount of magnesium oxide produced is, okay, so remember magnesium, when it reacts with oxygen, it's going to produce magnesium oxide. Okay, like that, then it's unbalanced like this. Okay, so now we are told that this one produced, it is 0.80, and we also know what this one, it is 0.48. How do we get this? Remember conservation of mass. Okay, conservation of mass in grade 10. If you are doing grade 10, it says now whatever mass of here should be equal to the mass of that. Okay, so it means here is going to be 0 for mass of O2. Here, remember, it is 0.80. This is going to be 0.80 minus 0.48, which gives us something like 0.32 grams. Okay, 0.32 grams. Now, we are done with step 1, which is converting to grams. Okay, then step 2, it is you finding the what? The number of moles. Number of moles of magnesium gonna be 0.48, which is my magnesium, divide by 24. Okay, that gives me something like 0.02 moles. And then number of moles of O. Okay, remember for oxygen we do not write O2, we just write O. Okay, yes. O here, I'm removing this O here because the minute I write 2, I'm just assigning Hore, it's gonna be how much. Okay, so just O is gonna be 0.32 divide by 16, which gives me something like 0.02 moles. Also, did you see that my product is magnesium oxide? So most of the chances are it's going to be 1:1. Then I say take the number of moles of Mg is to the number of moles of oxygen. It's going to be 0.2. Okay, 0.02 is to 0.02, which is the same as 1:1 when I divide by the smallest again. Therefore, it tells me that therefore my empirical formula, it is what? MgO, like that. Okay, let's have an exam question that they asked in an exam. Okay, let's have this one before we go to the one that they asked in an exam, because also this question that I'm coming with, they are similar. They come from an exam, just in the form of examples. Then it says butene has an empirical formula of CH2 again. Then the molecular mass of butene, it is 56 grams per mole. Then determine the molecular formula of butene. So now I'm given that the empirical formula, okay, it is CH2. The molecular mass of the butane, okay, it is 56. Determine the molecular formula of butene. So I need to calculate the molar mass of CH2 of my empirical formula, okay? Because this one here, it is the molecular mass or the mass of the what? Of the butene, which is my molecular formula, okay? So when I do the molecular formula, it's going to be 12 plus 2 into 1, which is the same as, is it 20? Sorry, not 24. 14, okay? 14 grams per mole, okay? Then now let's get in actual fact how much is butene. So I'm going to say I need the ratio, okay? In the ratio, you can say 56, the biggest one, divided by the smallest one. You'll get something like 4, okay? It is, your ratio, it is how much? 4. It means you're going to say, therefore, your molecular formula, okay? It's going to be what? 4 multiplied by my empirical formula, which is CH2, and then you'll get that it is somewhat what? C4H8. Okay, yes. Now let's look at the one that comes from an exam. It says what to us? Then this is also an example. Where is the one that comes from an exam? Let me quickly send it so that we're gonna work. Okay. Let me quickly find it so that we're gonna work. Seems like I did not take it. Really? Oh, it's on this one. Okay. Let me quickly send that one without wasting any further time. And then we almost hope the session. I hope you are still understanding what is the empirical formula and all of those. Okay, it's not that difficult. It's just 3 marks, grade 10 to 12, they're off. Okay, from grade 10 to grade 12. You need to know how to calculate that. Okay, yes. So let me quickly, I'm getting it. Don't know why it's taking time. Oh. Okay, where is it? Okay, it's delaying us. Okay, here it is. So let's copy that and bring it here so that we work nicely. Okay, so that we work nicely. Cool. So let's have that exam question. It says to us, uh, methyl propanoate, I can write how, I know what is methyl propanoate because I'm doing grade 12. I have done organic chemistry. So actually I have completed grade 12. I'm not doing grade 12. Methyl, it is, this is just an ester, okay? So it's gonna be methyl propanoate, okay? Prop means three, or I need here double bond O, then have whatever those there. So it's gonna be 1, 2, 3, 4. It's gonna be C4H8O2. This is its molecular formula. Okay, and I'm expecting the empirical formula to be something like C2H4O. Well, let's see if I'm correct or not. If you're doing grade 12, here is this. Okay, I'm challenging you. Define what is the empirical formula. It is the simplest whole number ratio of atoms in a compound. Then let's look at 6.1.2. 6.1.2. Determine by calculation the empirical formula, okay? Remember the first thing first, I need to calculate, to convert into mass. So I'm going to say mass of carbon is 54.55 grams. Again, then I need to convert mass of hydrogen, which is now 9.09 grams. Then mass of oxygen is going to be 36.36 grams. Okay, yes. When I add these, they should give me 100. Then now let's find number of moles. Number of moles of oxygen, so of carbon first, is going to be, do not forget the formula. Do not forget to write this formula first. Okay, yes. Just write it somewhere so that you get it, they mark it. Mass, it is 54.55 divided by molar mass, it is 12. It gives me something like 54.55 divided by 12. I'm going to use 4.55 maybe moles. Number of moles of hydrogen is going to be 9.09 divided by 1, which is just 9.09 moles. Then here, number of moles of oxygen is going to be 36.36 divided by 16. Gives us something like 36.36 divided by 16, something like 2.27. 725 maybe. Let me say 27. Okay. Moles. Okay. Then remember, what do I need to do? I need to align them. Number of moles of carbon, number of moles of hydrogen, number of moles of oxygen. Then it is 4.55, 9.09, 2.27. And then I'm going to divide by the smallest. Which one is the smallest? I check. Okay. Yebo. Then I say 4.4, or so 4.55 divided by 2.27. Get something like 2. Here, 2.00 something. Then 9.09 divided by 2.27, something like, divide, not plus, divide. So I get something like 4.044, okay, 4.004. So this is 4, and then this is 1. Therefore, it means my empirical formula is going to be what? My empirical formula is going to be what? It's going to be C2H4O. Let's check if I was correct. Yes. C2H4O. Okay? Yes. And remember, what did I say? It's going to be methyl. It's going to be C4H8O2. Now, let's check. They say now, calculate the molecular formula. Okay? Molecular formula, remember, we need to find the ratio first. Between what? So we say, for molecular formula, which is 6.1.3, 6.1. Okay, let me write it here. 6.1.3. I'm gonna need what? The sorry, molar mass of C2H4O, which is 2 times 12. It is 24 plus 4 plus 16. It's going to be something like 44. Really? 44. Yes. I get molar mass of 44 grams per mole. Then remember, I need what? The ratio. The ratio is going to be what? What is the molecular mass of the compound? It is 88. Then I'm just going to say 88 divided by 44. Then I get something like 2. Then it means now my molecular is going to be sorry, 2 into what? C2H4O, which is the same as C4H8O2. Okay, here it is. If you're doing grade 12, you're not supposed to get this incorrect because you already know the what organic chemistry, how you write the formula from the given name and how to draw the structure. Okay. Then lastly, for the series, let's talk about water of crystallization. Okay. They ask this in grade 10, then in grade 11, not really that much, grade 12, not at all. So let's have that question for water of crystallization. And it's just an easy, not a difficult part. Just see how much the ratio between water and whatever that compound it is reacting with there. So I'm told that I'm not sure if it is visible nicely because here it is dim. It says to me 13.2 grams of sample zinc sulfate. Okay. Zinc sulfate was heated in crucible. Okay, in a crucible. Calculate the number of moles of water of crystallization if 7.4 grams of solid remained. Okay, so remember zinc sulfate, it is all of these again, all of these, right? So now we need to know that how much of actually we need to calculate the number of moles of water of crystallization. Water of crystallization, it is this one. Okay, so zinc sulfate, it is that one, was heated in a crucible. Calculate the number of moles of water of crystallization if 7.4 grams of solid remains. The solid, it is the what? It is the zinc sulfate. Okay, then we're going to say we know the mass of zinc sulfate. It is equal to 7.4 grams. Okay, but the total mass of this whole part, it is how much? It is 13.2. So it means we're going to say mass of XH2O is going to be 13.2 minus 7.4, which is the same as 13.2 minus 7.4, something like 5.8 grams. Okay. Then just convert these to number of moles. Convert these to number of moles. It's going to be number of moles of zinc SO4. Remember, this topic is all about number of moles. Okay, let's write the formula first. Okay, just write the formula somewhere. Gonna be 7.4 divided by, what is molar mass of zinc sulfate? Gonna be zinc. How much is zinc? 65. I'm sorry if I got it incorrect. 65 plus 32 plus 4 into what? 16. I get something like 161. Let me quickly confirm the molar mass of zinc. I do not need to make mistake. Molar mass of zinc, yeah, it's 161. Okay. 61. Actually, here it's just what? 161. And then I get something like 0.064. So 0.40 moles. Okay. Then let's get number of moles. Number of moles of what? You can get now number of moles of our water. Okay. Of our water, which is going to be 5.8 divided by 18. Okay. then it gives me something like 0.32 moles. And remember, I want to know zinc SO4 multiplied by X H2O. I need to know how much is this X, right? So how can I do that? I'm going to say, what is the ratio between the two of them? The ratio between the two of them is going to be what? You can say the mole of water divide by the what? By mole of uh of the anhydrous salt. So, or just the solid, okay? The solid that remained, okay? Or you can say of the zinc sulfate, okay? So it's gonna be what, when you do that mathematically, it's gonna give us mole of water, it is 0, what? 0.32, and then I'm gonna divide that by 0, actually here, yeah, 0, remember we already know the mole of this, it is 1 here again. So 0, actually do it like this so that it does not confuse you. Okay, just do it like this. Number of moles of H2O is 2, or just start with this one. Number of moles of zinc SO4 is to number of moles of H2O, just like the same as we use empirical formula. So this one is going to be just 0.064, so not 6446. Remember it is 46 there. Then is 2, 0.32. Then let's divide by the smallest one. 0.046, 0.046. We already know this one, it is 1. Okay, then let's look at this one. 0.32 divided by 0.046 gives me something like 6, it gives me something like 6.95, blah blah blah, which is can be converted to what? To 7. Again, therefore, it means now our formula it is what? ZnSO4 multiplied by 7H2O. Okay, so yeah, it's basically that, and that's all for the series of these videos. Then yeah, we will meet again on the next topic on some other day, whenever you'll find it. Okay, so yes, thank you very much for watching the series of quantitative aspect of chemical change. Hopefully you enjoyed and understood the concept, and good luck.